Hi everyone, welcome back to the channel. This is third part of our computer vision and machine learning series, where we are diving deep into the real world object detection using YOLO Model 8 and YOLO Model 11. In the first two parts, we compare the performance and architecture of the both models. Now it is time to get more hands on. In this current episode, we are focusing on training phase, looking at how the model learns, improve, and sometimes struggle. We will explore training validation loss over time, the matrices lodged in the results.csv file, and how to interpret these values to better understand the model's performance. If you are curious about how to read these numbers, visualize the learning curves, or fine tuning your result, you are in the right place. So let's dive in. We continue from we continue from last part of our video, YOLO 11 versus YOLO 8. Now we visualize the results and we check what was the problems during training and validation. If we find any overfitting, any problems, is augmentation is required or not. So let's see how these results and everything looks like visually. So first of all, we need to check where exactly these matrices are available. So we need to go to YOLO 8 models training model set. We go inside the run and detect. And inside we can see we have YOLO 3 and YOLO 2. YOLO 3 is basically YOLO 8 model. So we inside there we can see results.csv. So we have to go through these results.csv parameters. We are taking care of this epoch, and then we have a time, trend box loss, trend CS loss, and these parameters are very critical for training and losses. So let's get started with the imports first. So first thing we need to import is pandas in order to read the CSV file. So import pandas is PD. Yes. Then we need to import matplotlib. Matplotlib dot pyplot is plt, and then we say matplotlib inline in order to display this here in the Jupyter lib. So first of all, we need to make a function define YOLO train plot. We need the CSV path results underscore CSV path. First thing we need to get the data set. This file we said that pd.read underscore CSV. Yeah. Okay, we just say results CSV underscore path. So let's check whether this function is reading this CSV file or not. So let's call this and we say df equals to this one. For example, not df equals to, but we just call it So we need the results underscore CSV part. So it's like we have this part. For example, we go inside. Mhm. We go run, say runs underscore detect underscore. Then we have here train YOLO 3, YOLO 2, train underscore YOLO 3 slash. And then we have results.csv. Results.csv. Okay, so let's check. Let's print the DF here. Print SDF. Yeah, it's reading the file here, so it's working. So we don't need to run the file. Now, next thing we need to check is train underscore loss equals to df. We say train slash box. This would be box slash loss. Then we have validation loss equals to mdf validation box loss. And let's print those. Let's go. Loss whether these are working or not. Train box loss. No. So train box loss. Train. Let me check train box loss. Train box underscore loss is not. Yeah. Not this one. What is one? Yeah. This one is the same. Yes, it's working. So it's like a train underscore box loss, train underscore whale underscore box loss. So we have a training loss and validation loss values here. Now we need epoches equals to df epoch. Next we need epoches, then we have, but we need to start epoch from first value, like it starts normally in the CSV file from 0 value, so we need to start from the first value. So epoch will start from the first value. Then we have map map 50 equals to this one, and map 50 underscore 95 equals to this one needs to be df. Then we say matrices matrix dash. Then we have sorry, map maybe 50 slash B, and then we have this one. And same way, we have this one. You can copy here, is 95. Okay. Let me print these whether these are working or not. Yes. Print 50. Mean average precision 50. Box B matrix. Let me check the matrix precision B matrix matrix MAP 94 B is one. Put together. Not this one. Okay. Yeah, now working. So now we got all four loss values and we already know e purchase. So next thing we need to do is plot a figure plt dot figure. Then we need to define the size. How we have to plot two subplots within the size. One is for the trend and validation loss, and another for the accuracy loss. For example, size would be 12/5 would be fine for us. Then we say plt dot subplot would be one row, two columns, and on first position. So we have plt dot subplot first row, two columns, second position, and then we have plt dot show, and we have normally we do have plt dot title and plt dot legend, and legend, and then we have plt dot x label and plt dot y label. These are common values that every PLT has. PLT plot, sorry, X and Y values, PLT dot plot Y value. So we need all these things for all both of them. Make it quicker for you guys. Let me show how it looks. Y here, X here, X here, for example, and Y here. Let me show you how things looks like. Okay, no problem. Integer, okay, 1, 2, 2, and everything is fine. Okay, so there was a problem with the big size, and then this one. Let's check this one now. Fig size is not defined. Okay, figure, big size. PLT.figure. Big size equals to, okay, this is like a big size equals to this one. Now let's check. Yeah, we have empty two subplots, like first position and second position. Now you can see. Now, okay, now let's fill these all. First of all, BLD and then X levels and Y levels. And then this one. Okay, so first we need here epoches, which is epoches, comma. Then we need, for example, train loss and validation loss. Validation underscore loss. Then we need a style. What sort of a style we want to see? We want to see BO slash comma, then label equals to label should be training loss, training loss. And then we have second equals comma. That's a training loss here first. Train loss. And then we have validation underscore loss. And second, we have, let's discuss a little bit later. Label equals to validation loss. Here we X level, we have epoches. So epoches, and here we have loss. And target is training versus validation. Okay, let's check on empty graph. Yeah. So you can see this BO is working here on blue line and the other is not working. So let me check what was it. So it needs to be like R into this one, maybe, yeah. Let's check. Yeah, now both working. And then we have this PLD, we have X level and Y level to come. This first E, which is MAP 50, then it just comes to level equals to this one. What was level? And the level is like MAP MAP 8 0.5. And this one was like a go slash, and then we have equals. Then we have map 50 underscore 95. We just confirm this one. Yeah, this one here. And then we have style with M slash this one, and then the label equals to MA, sorry, MAB 8 0.5 dot 9 0.9. X level can be epoches, and then we have here loss. No, sorry, mean average. Precision, we call it MAP. Yes. And the title would be Precision 50. Mean average precision 50. So there is no 0.5. 50 slash. Yeah, let's check. Yeah, very good. We can see the training and the validation loss and mean average precision and mean average precision 0.5 and 0.95. Yeah. So our loss after epoches, after each epoch, our loss, for example, from it starts from 2 to till, yeah. So epoch goes to epoch. Yeah. DF. It epoch is here, epoch. Yeah. So just DF. Let's check epoches. Yeah, epoch. Okay, thank you very much. And let's discuss these things in the next video.